All right, so in our last video, we basically saw what the relationship was between exponential functions and logarithmic functions, and we noticed that they were inverses of each other. So we basically know that fact, but we know how to draw exponential functions, but we don't know how to draw logarithmic functions. So I'm just going to show you how to do that in this video. So since we know that they're inverses of each other, and we know that for example, say I have y is equal to 2 to the power of x, right? I know that my exponential function has a horizontal asymptote, okay? And since I know that the logarithmic functions are inverses, so what that turns out to be is that if I have y equals log, say, base 2x, okay? So if they're inverses, in other words, things are just flipped around, log functions have a vertical asymptote. Okay, so all log functions have a vertical asymptote. Okay, and they look like this. Okay, I should probably just draw the right. So since they sort of reflected across each other, log functions basically approach the y-axis but never reach it, and then they go off towards the right, just like this blue line shows. So let's draw, say, a couple of functions and see how that looks like. So say, for example, I have y, oops, let me just do it in white, just to make it easier. So say I have y is equal to log base 2 x plus 2. And since it's x plus 2, what that means is that normally the asymptote, the vertical asymptote for log would be in the y-axis, but since it's plus 2, it's moved to the left. If you remember that this is x plus 2 inside the function, so it must be moved to the left. So basically your asymptote would be there, and since there's no other funky sort of reflections or transformations, we can now have our line, or let me just draw it in red maybe. Actually, no, I'll stick with blue. So our function now looks like this. Okay, so that's the log graph. It's basically this line here is x equals -2, right? Because that's the vertical asymptote. So what happens if I have, say, y, so let's do the same thing here. So let's do negative log base 2 x plus 2, right? And what that would do in this case, okay, I'm just going to use, say, a red line. So we'd keep the same asymptote, but it's that, x equals -2. So x equals -2. But this, if you notice, this negative here is just a reflection across the y-axis. So in other words, it would reflect this way, right? It would just go, it sort of goes this way. I'll just erase that. So it just continues towards sort of infinity in this way. So you can see like there's sort of a reflection that's going on in the x-axis. So this is a reflection in the x-axis. Let's do one last one, just to sort of clarify how this all works. Okay, so what if I did y equals, so we'll just keep the same one actually. So let's do log base 2 x plus 2, say plus 3. So would this plus 3 move the vertical asymptote? Let's see, let's find out. So the answer to that question is no. It would not move the vertical asymptote at all. The vertical asymptote remains at x equals -2. Okay, so basically all it would do is it would just move all the y values up by 3, right? And if you move all the y values up by 3, that does not change the vertical asymptote at all. It just means that everything is moved up by 3. So basically it would just be like a lot higher. And that's really the only difference. So the difference between this graph right here and the previous one over there is that this graph over here is just a little bit taller, it's a little bit higher. But the asymptote remains the same, just as it does for this one, right? So there's no real difference in this case. All right, so I hope that's just enough of an overview for drawing logs and logarithms and exponential functions in general. So I'll see you in class next time, and that's it for the review for exponential functions and logarithms. Thanks for listening. Bye.